morning, squad. Mr. Herr here on this I Need More Coffee Wednesday morning. Hopefully everybody on your end is healthy, wealthy, and wise. Today, ladies and gentlemen, we'll talk about mutually exclusive events when it comes to probability. We started probability yesterday when we were talking about independent and dependent events. That's whether or not the first event has an impact on the second event. If there's no impact on one another, those are independent events. If there is an impact, then those are dependent events. But I digress. Today, like I said, we'll talk about mutually exclusive. If you're saying, Mr. Herr, what's that fancy term mean? It basically means is there an overlap, between the two categories? For instance, if you were going to say, when I go out to eat, I usually get a Coke or a Pepsi. Well, those two are mutually exclusive. There's no overlap. There's no unique drink called the Pepsi Coke. There's no overlap between the two categories. Where on the flip side, if you said, well, Mr. Herr, when I go out to eat, I usually get a Coke or a cherry soda. Well, yes, there's Coke. Yes, there's sodas that have cherry flavored, but there's an overlap there in cherry Coke. Okay, so when you're figuring out probabilities, that overlap has an impact. We'll talk about that in our notes. We'll talk about ones that are mutually exclusive and ones that are not. The notes go pretty quick. There's only 6 examples in our notes, and then an 8-question PDF. Hey, if you wouldn't mind, try to show your work. I know with probability it's tricky. There's not a ton to show. But yeah, other than that, let's do this thing. As always, here comes the spring. Sorry about that. This is a perfect time to pause the paper and, grab yourself, or pause the paper, pause the video and grab yourself a piece of paper or pencil. That way we can follow along here. Okay. Determine if the scenario involves mutually exclusive events, then find the probability. Okay. A litter of kittens consists of 2 gray kittens, 2 black kittens, and 2 mixed colored kittens. You randomly pick one. The kitten is gray or mixed. Okay. Well, gray, there's 2 of them out of what appears to be the 6. And mixed, there's 2 of them out of the 6. What we don't have, though, is we don't have overlap. There's no gray mix or anything of the sort. So this is mutually exclusive. There is no overlap between the two. So you might say, well, Mr. Herr, that's great, but how do we figure this out? Well, we take the probability when it's mutually exclusive and we just add each individual category. So the chances of getting a gray kitten is 2 out of 2, 4, 6. So 2 out of 6, that's our gray. Or a mixed color. Well, that's 2 out of 6. And in OR problems, this is different than what we did yesterday. In OR problems, we add our probabilities because the chances of getting gray, 2 out of 6, mixed, 2 out of 6. So either or, the chances of getting one of those 2 is 4 out of 6, or of course, 2/3. Okay. Mutually exclusive is definitely the easier of the two. You just add your categories and go. All right. Let's talk about when there's overlap. A box contains 6 red playing cards numbered 1 to 6. The box also contains 6 black playing cards numbered 1 to 6. You randomly pick a playing card. It is red or has a number greater than 4. Okay, so let's look here. Sorry for losing my voice. There are 6 red playing cards. There we went. Okay, and 6 black, so that's 6 out of the 12 are red. Sweet. Or has a number greater than 4. Well, that means it could be 5 or it could be 6. There are red playing cards. There's a red 5 and a red 6. And there's a black card, a black 5 and a black 6. So that's red 5, red 6, black 5, black 6. That's 4 total. 4 out of the 12 are greater than 4. But right here, there's an overlap. So these are not mutually exclusive. And we actually already talked about it because, yes, there's red cards, but there's also red cards that are greater than 4, specifically the red 5 and the red 6. They were double counted. The red 5 and red 6 are in here. The red 5 and red 6 are in there. So what you can do is you can take your individual categories, add them up, but then we subtract the overlap. Well, the red 5 and the red 6 were counted twice, so I'm going to subtract the red 5, the red 6, so that's 2 out of 12 cards. I'm going to subtract those. Then you just add and subtract respectively. 6, 4 minus 2. Oh, that is 8 out of 12, which of course reduces to 2/3. Sorry that they reduced to the same thing. My bad, fam. Okay. The not mutually exclusive one, those are the hardest. So let's sort of stick on those same lines. Jump down here to number 4. There are 12 shirts in your closet, 6 blue and 6 green. 2 of the blue shirts and 3 of the green shirts fit well. The others are too big. Been there. You randomly select a shirt to wear. It is green or is too big. Okay, well, let's look. Out of the 12 shirts, 6 are green. Okay. 2 of the blue shirts and 3 of the green shirts fit well. So that's telling me that 2, 3, 5 of your shirts fit well, which means the others are too big. That means 7 of our 12 shirts are too big. Womp, womp. Okay. So what's the probability it is green or it is too big? Well, are these mutually exclusive events? Well, no, they're not mutually exclusive because you could have a green shirt that's too big. That's not too hard to imagine at all. In fact, we can figure this out very quick. Oh, it just dawned on me. I've been spelling this wrong. You guys are used to that. My fault. Okay. So look here. Green shirts that are too big. Well, how many of those do we have? If 3 of the green shirts fit well, that means 3 of the green shirts are too big. They've been double counted. So I have to subtract 3 out of that 12. Okay, then we're good to go. 6, 7, 3. Okay, that's 10 out of 12. Or last time I checked, that reduces to 5/6. Okay. Last but not least, one more, and quite frankly, this one is mutually exclusive. We're good to go here. A cooler contains 11 bottles of sport drinks, 3 lemon lime, 4 orange, and 4 fruit punch. You randomly grab a bottle. It is lemon lime or an orange. Well, there's no overlap here. So these, you're either orange, fruit punch, or lemon lime. So these are mutually exclusive. We have 3 lemon lime out of the 11, or 4 orange out of the 11. Just add and go. Hey, 7-Eleven. You might say, old timer, is it really that easy? Yup. Okay. Mutually exclusive is definitely easier than when they are not mutually exclusive. Read carefully, think through the scenarios. There's no doubt in my mind you got this. All right? Hey, please leave me a comment. Let me know if this stuff is too easy. I will tell you, though, the probability unit does get harder. You have my word. Let me know if it's too much, if it's taking up too much of your time. Let me know if you want to throw your iPad into the street and run it over with a dump truck. These are the things that I miss hearing, squad. So I hope you have a good day. We'll talk to you soon. Peace.